So our solar system has a visitor from another star system, and its name, 3I/Atlas.
This thing is huge, it's fast, and it's weird, which forces us to ask that very question. Okay, let's look at the case for intent. Harvard astrophysicist Avi Loeb sees multiple anomalies here. Statistically, we should have found 100,000 smaller objects before finding one this massive. A huge red flag. And its path is just strange. It's almost perfectly aligned with our solar system's plane. The odds of it lining up for flybys of Jupiter, Mars, and Venus, 1 in 20,000. Like Loeb says, you have to wonder if the dice are loaded. And this next clue, it's a big one. We see gas jetting from it like a comet, but its path isn't changing. So what gives? Well, it's because it weighs at least 33 billion tons. It's just too massive to be pushed. But, the mainstream scientific community, they have a much simpler take on all this. They say we just thought it because it was big. The rest? Glitches. And just weird comet stuff. So the big question is, what happens next? A few key dates will put both theories to the test. All right, here's the timeline. This is where we could finally solve this mystery. October 3rd, a Mars orbiter gets our best look yet. But the real test, that comes later. Then October 29th, it ducks behind the sun. A perfect time to pull this kind of maneuver. Will it slow down? Maybe even stay? We won't know till it pops out again in late November. We'll recalculate its trajectory, see if anything's changed. Is it just passing through or setting up shop? You see, this isn't just about one object. It's really about how we search for answers out there. So if it's a comet, fascinating science. But if it's a probe, that changes everything, forever. So when Atlas comes back into view, will it still be on its way out? The data is coming. Are we ready?
Welcome back. We're diving straight into a really interesting piece today, an analysis of 3I Atlas, arguing it might be more than just a natural comet.
Yeah, looking at the case for intentionality based on its, unusual characteristics.
Okay, let's jump right in. First up, how the whole argument is put together, the structure.
Right. I get the goal here. You're lining up different pieces of evidence, trying to show the odds of it being natural are just vanishingly small.
That's the idea. Build that tension with the probabilities stacking up. But I felt the structure itself was maybe working against that?
I think so too. The presentation suffers from significant structural repetition, which undermines the cumulative force of the evidence streams.
Okay, so what's the issue specifically?
The weakness, as I see it, is that core statistical idea. Finding something this big, on this precise path, this early, how unlikely that is.
The 1 in 20,000 number for the trajectory stuff.
That and the general improbability concept. It gets repeated in the chapter on size, then again when you discuss trajectory, then again with mass. Chapters 1, 2, 3, even 6 touch on it.
Ah, I see. So the audience is kind of forced to process that same, wow, that's unlikely, logic multiple times for different data points.
Exactly. And it really slows down the momentum. You're basically relitigating the core statistical tension instead of building on it.
Right. It makes the final conclusion feel less like a big reveal and more like, okay, yeah, we've heard this improbability argument before.
We need that punch saved for the end,
So structurally, how do we fix that? How do we stop it feeling like we're just going in circles with the stats?
Well, the suggestion is a pretty fundamental reorganization. Think about presenting the evidence in 2 distinct pillars. Maybe mechanical and orbital evidence in one.
Okay.
And then physical and compositional evidence in the other. Completely separate, non-overlapping.
Right.
Then you hold back that whole statistical improbability calculation. Don't mention it in the pillars. Save it for a unified synthesis section right at the end.
Oh, okay. So the statistics become the bridge connecting these 2 separate lines of evidence, rather than the drumbeat within each one.
Precisely. It gives the statistics their proper role, tying independent anomalies together to make the final powerful point.
That makes a lot of sense. Like building 2 towers, then showing the improbable tightrope connecting them, much stronger. So practically, what would that look like?
Okay, concrete examples. For the first pillar, let's call it the fine-tuned trajectory or something.
Mm-hmm.
You put all the orbital mechanics stuff there. The 1 in 500 odds for lining up with the ecliptic plane. Those incredibly precise close passes by Jupiter, Mars, and Venus.
Yeah, that sequence is remarkable.
And that combined 1 in 20,000 probability for all those orbital coincidences happening together. Bundle it all tightly in that one section, pillar 1. Done.
Okay, so that's the how it moved pillar. Then the second pillar handles the what it is part.
Exactly. Pillar 2, maybe the mass and composition anomaly. This gets only the physical data.
So the initial size estimate, the big 20 kilometers?
Yep, that one. Then the refined Hubble data, putting it closer to 5.6 kilometers. Crucially, that huge 33 billion ton mass estimate.
Derived from the lack of non-gravitational acceleration, right? The fact it didn't behave like a normal comet, pushing itself without gassing.
Correct. That mass constraint is key. And also the weird chemistry, that 8-to-1 ratio of carbon dioxide to water ice. All of that goes into pillar 2.
Okay.
Then, after you've clearly laid out pillar 1, unique path, and pillar 2, unique object, then you hit the audience with the unified statistical synthesis. You say, look at this path, look at this object, what are the odds? That's your climax.
Okay, yeah, that feels much cleaner, much more impactful. It builds suspense. So, assuming we get the structure right, that leads to the next point. How we actually talk about this powerful data. The tone.
Right. Because even with a perfect structure, the delivery matters hugely, especially with such complex, potentially controversial stuff. And that leads to the second critique point.
Which is?
The use of overly dramatic and conversational framing compromises the credibility and intellectual weight of the sophisticated scientific concepts presented.
I think I know what you mean. There's this sophisticated science, like deriving 33 billion tons from subtle orbital mechanics.
Really complex calculations, yeah.
But then it's sometimes introduced or wrapped up with language that feels a bit too casual, maybe even sensational?
That's the weakness, precisely. You have these really high-stakes technical discussions, the mass derivation, the reverse solar Oberth maneuver concept, which is fascinating,
And they're immediately undercut by phrases like, here's where it gets wild, or, the calls to action you sometimes see online. Like and subscribe style stuff.
Right. That can definitely create a disconnect.
It creates cognitive dissonance, yeah. If your audience understands the physics, and presumably they do given the topic, that kind of framing actually dilutes the intellectual authority. It feels less like a serious scientific analysis and more like clickbait, almost.
Yeah, that 33 billion ton number is mind-bending enough on its own. It doesn't need hype. Okay, so what's the suggestive fix for the tone?
It's pretty straightforward, really. The suggestion is to adopt a more consistent, measured, and objective tone throughout. One that actually reflects the highly technical nature of the material you're discussing.
Let the data provide the drama.
Exactly. Save any high-impact, slightly more dramatic language only for those key summary moments or hypothesis transitions, when the evidence itself genuinely warrants that sense of awe. Not when you're just trying to keep attention. Build the impact through the sheer weight of the data's implications.
Okay, so less conversational filter, more direct engagement with the science. Can you give some concrete examples of language to maybe dial back?
Sure. First, definitely remove any obligatory intro calls to action. Things like hit that like button or personal anecdotes right at the start. They just break the focus from that intense initial hook about Atlas. Get straight to the science.
Right.
And then, when discussing things like the visual observations, stick purely to the observational data. So instead of a metaphor like, no tail, just headlights, which is evocative, I grant you.
But maybe not precise enough?
Right. Replace it with the neutral, factual description. Talk about the observed, teardrop-shaped cocoon of dust and the unusual forward glow. And immediately follow that with the technical assessment that this might have been an artifact of motion blur during the Hubble exposure.
Ground it in the observation and the potential instrumental effects first.
Yes. The raw anomaly is compelling. Let the strangeness speak for itself through precise language, not through catchy metaphors.
I agree. With anomalies this specific, technical precision really does trump metaphor. Okay, that makes sense. Which brings us to the third and maybe most crucial area. How the material handles the counterarguments, the natural explanations.
Yes, the scientific skepticism part.
If the tone is right, the argument itself needs to be balanced and robust.
Absolutely. And while the material does bring up natural explanations, there's an issue with, let's say, proportional representation. The material introduces natural counterarguments effectively, but fails to allocate sufficient proportional weight to conventional explanations, prematurely forcing the argument toward the technological hypothesis.
Okay, so the weakness is we mention the natural possibilities, but maybe don't give them enough airtime before jumping to the more exotic explanation.
Pretty much. Take the mass constraint again, that 33 billion tons. The piece establishes this technical minimum mass needed to resist the observed lack of outgassing thrust. But then it transitions almost immediately to the most speculative idea that it must be a hollow structure, an engineered artifact.
Without fully exploring how a natural object might appear that way.
Exactly. It kind of dismisses, or at least doesn't fully wrestle with, plausible natural alternatives. Could a natural comet be incredibly porous, like almost fluffy on a cosmic scale, giving it low density despite the size?
Like an aerogel comet or something?
Sort of. Or could there be systematic errors in measuring that tiny non-gravitational acceleration? By jumping past deeply considering those, the argument feels, it feels like it's rushing towards the desired technological conclusion. A bit biased.
And that's actually counterproductive, isn't it? If you want to convince scientists, you have to show you've rigorously tried to disprove your own exotic idea with conventional physics first. Glossing over that weakens the case.
It weakens it significantly. It looks like confirmation bias is driving the narrative. So, the suggestion for improvement is quite critical. Strengthen the robustness by dedicating a specific, balanced segment to really grappling with the strongest competing natural explanations for each core anomaly.
Before you pivot to the technological alternative.
Yes, absolutely before. You need to show the audience why the conventional physics is strained, why the natural explanations, while possible, might be even more contrived or unlikely than the technological one. Exhaust the mundane first.
Okay, give the standard physics a fair fight. Show where it struggles. Can you give concrete examples of how to do that fairly?
Okay, for the mass issue. When discussing the 33 billion tons alongside the refined 5.6 kilometer size, you must explicitly explore how a natural comet could achieve that. Discuss extreme porosity. What kind of formation process leads to something potentially more like a giant, loosely packed dust bunny than solid rock or ice?
Force the audience to consider that geological strangeness.
Make them really think about how weird even the natural explanation would have to be.
Exactly. Make them grapple with the implications of that before you offer constructed, not formed, as the alternative. The difficulty of the natural explanation then becomes part of the evidence for the alternative.
That strengthens the argument by showing the dilemma clearly. What about the CO2 ratio?
Same approach. For the unusual 8-to-1 carbon dioxide to water ice ratio, you need to clearly present the strong natural explanation that's already out there. That Atlas might have formed in an extremely cold part of its home star system, where CO2 ice is more stable than water ice.
Precisely. Under those conditions, CO2 dominance might be chemically expected. So you present that robust, natural model fully. Acknowledge it. Then, you can perhaps discuss why finding an object from such a specific, extremely cold formation zone might also be statistically unlikely, or if other features contradict it. But you have to give the natural case its due first.
Okay, so systematically address and evaluate the limits of the natural explanations. That makes the eventual turn to the technological hypothesis feel earned, not assumed.
Earned, exactly. It becomes more powerful, more scientifically sound, because you've shown you've done the due diligence.
Right. That wraps up our main points on this really thought-provoking analysis of 3 Atlas. We've covered 3 key areas for refinement.
Yep, 3 main things aimed at boosting the impact and the intellectual credibility of the case being made.
First was about untangling that structural repetition.
Right, getting away from hammering the statistics repeatedly and saving them for a powerful, unified climax.
Second, aligning the tone. Making sure the language consistently matches the serious, technical weight of the scientific evidence.
Letting the data speak for itself, essentially. Less hype, more precision.
And third, and perhaps most fundamentally, ensuring a rigorous and fair balance when presenting the natural counterarguments versus the technological hypothesis.
Showing that you've truly wrestled with the conventional explanations before suggesting something extraordinary.
So the actionable steps boil down to this. First, reorganize the evidence. Create those two distinct pillars, orbital mechanics and physical composition, and reserve the statistical synthesis for the end.
Second, go through and scrub the language. Replace the overly sensational phrases and metaphors, especially things like headlights, with precise, neutral, technical descriptions of the actual observations and data.
And third, dedicate specific space to fully exploring the natural explanations, things like extreme porosity to explain the mass or ultra-cold formation conditions for the CO2 ratio. Give them their proper weight before arguing they fall short.
Nail those three things, and this analysis goes from intriguing to potentially paradigm-shifting, built on a much more solid, scientifically defensible foundation.
Absolutely. We genuinely look forward to seeing how these suggestions might shape the next version. Please do consider implementing them, and feel free to submit the revised work back for another look.
Yeah, definitely. It's fascinating material.
Until next time, keep refining, keep questioning.